This is Tim Robinson with the Kentucky Transportation Cabinet's Drainage Branch, and today I'd like to go over the new TC61507 channel line analysis spreadsheet. Okay, you see we have that open. We'll go ahead and enable content. Right now I'd like to go through the different tabs that we have on this spreadsheet. First we start with the instructions, which we're going to be going over. We have our NOAA data entry. We have our basic data input tab where we can put all of our channel lining information as well as the project information. And then we have our shear analysis tab, which calculates the maximum shear on a section of channel based on the 10-year return event and the maximum slope for the range of channel we're looking at. We have the maximum depth to line tab, which also uses a 10-year event, but it looks at the minimum slope of the range of channel we're looking at to determine the maximum depth of flow and thus the depth of line that we're going to require for this section of channel. And then finally we have the 100-year check, which also utilizes the minimum slope but uses the 100-year event to use as a check. And then finally we have a quantities spreadsheet quantities tab, which should give us the quantities for the range of ditch and the type of lining that we are analyzing for. So the first thing I'm going to do is come over here to the data entry. You can see I've already entered my data, and the data immediately populates the cells at the top of each of these sheets. So if I change this to Jefferson, you can see it immediately updates the sheets on the other tab accordingly. Next, I want to go ahead and look at the NOAA data entry. So what we're going to want to do is go to the precipitation frequency data server for NOAA. So we'll go ahead and pull that up, click on Kentucky, and we want to make sure that we pick on precipitation intensity. Okay, this is in Henry County, so we're going to go ahead and zoom in. And we're going to go ahead and pick our, it's right over here. And so it should automatically update our intensities. You can see down here you have an area where you can actually download the data in a CSV file. That CSV file opens. We'll go ahead and actually highlight the data, right click and copy. And then come into the same range on our spreadsheet on the NOAA data tab. And now we have our NOAA data entered. Okay, so let's go back over to our data entry tab and go ahead and put our first ditch in. Alright, we'll look at one on the left side. From 100 plus 00 left to 103.50 left. Okay, it's going to be a drainage area that's half an acre in size. We're going to say that it has a rational C value of 0.45. We're going to go ahead and put our time of concentration in. In this case it was 5 minutes. Now I know a lot of you all say, wait a minute, the minimum time of concentration is 8. Okay, well actually it's the intensity from the minimum time of concentration we use. The time of concentration is whatever it is. This spreadsheet will look, and if it's less than 8 minutes, it will automatically default to the intensity for 8 minutes for the return interval we're looking at. I'm going to put a little have a slightly smaller time of concentration for the 100-year, and the reason being is that the iterative process that HEC 22 uses each storm event to calculate time of concentration, and usually the larger events have a slightly smaller time of concentration. If you use something like TR55, you'll just have one time of concentration. All right, this is going to be a roadside ditch, like a normal ditch or a special ditch that actually has a foreslope there attached to the hinge point. All right, our minimum slope is 3.5%. We enter that as a decimal. And our maximum slope is 5%. We have a pull down here where we can actually pick from our different types of linings. You can see we have different types of riprap classes: erosion control blanket, turf reinforcing mattress, grout riprap, and rock cut. We're going to pick erosion control blanket. And we're going to say that the length of ditch, we'll say that the left side is on the outside. And so we're not doing it by station, we're doing it by the actual linear length of channel that is being lined. So it's a little longer than the 350 feet of station that we have here. All right, so we've got our data entered. We'll go ahead and hit Control D, which activates the macro for this. And you can see it went through the various tabs and ran the macro. The way we can tell if macro conversion, we look and see on each of the tabs the delta Q should have gone to 0. So what it's doing is it's taking our known Q and it's comparing it to the calculated Q for the channel for this, that we're using the Manning's equation on, and it keeps iterating until it gets the correct depth, and the depth and the flow match the actual given flow value. You can see it converged for there, there, and there on all three of our tabs. So we're good to go. All right, I want to take a look at a few other things. This intensity, if you go look it up, you can see that it defaulted to the 8-minute time of concentration for the 10-year here. It's a 6.22. And the same thing on the 100-year. It went to 8.27. So you can see it went ahead and it calculated the actual shear on the lining, 0.78 pounds per square foot. And it also pulls off the, for grass linings, it will just pull off the permissible list, in this case 1 pound per square foot. And it actually goes through a calculation for the riprap, which we'll get to in a little bit. So we can see that the shear value is acceptable. We can see that it calculated the depth, which is 0.29 feet. I was using the minimum slope. That the 100-year check is 0.33 feet. So we can check that, make sure it's not going to threaten any structures or get over the road. And then finally, where we put in the length, it's gone through and given us a quantity. Now you have the 1.5 feet. That's based on our specifications. Has information about the erosion control blanket. You'll see that we really don't have anything yet about turf reinforcing mattress. We're working on getting something on that in. I don't know, we'll have to look at that 1.5 feet, but right now, because of the specifications, that's at 1.5 feet. We'll see that the TRM just comes in at 1 feet here in a little bit. But you can see we do have a quantity for that 362 feet of 583 square yards. So for our next ditch, I'd like to look at the drainage manual, specifically DR 509-1, where we talk about documentation of drainage calculations in drainage folders, or now drainage submittals, and that it's only required for ditches that exceed the following criteria. For channel slopes that are less than 1%, you can go up to 2 acres without providing the documentations. And if it's between 1 and 2%, does not exceed 2%, you can go up to half an acre with your area before having to provide the channel calculations. So to illustrate that, let's look at our next ditch. Okay, we're going to look at one on the right side, same range. And this one is going to be 4/10 of an acre. And we'll have a rational C value of 0.6 for this one. This one will say that we had a 3-minute time of concentration for the 10-year and 2.95 for the 100-year. Alright, and this one is more of a surface ditch. 3-to-1 side slopes, 2-foot flat bottom. The maximum slope for this one will be the minimum slope will be 0.5%, and the maximum will be at 1.5%. We're going to look at erosion control blanket again. And in this case, it just runs along with the center line. Okay, so let's rerun our macro. We can see when we come down here that it actually says C note 1. So we got down here, note 1 says that if the slopes are between 3/10 of an acre and 2, or 3/10 of a percent of slope and 2%, and it's draining under half an acre, that calculations are not required. Okay. We goes ahead and still analyzes for the maximum depth line and the 100-year check. And again, we used the erosion control blanket since the calculations weren't required, but it went through and did the calculations again using the 1.5 feet of depth to line. So let's go ahead and look at another situation now for the other situation we have that actually doesn't require the calculations. So in this case, we've got a drainage area of 1.5 feet and slope, a maximum slope of 0.75%. So we run our macro here. Again, we see we get note 2, which again, note 2 talks about the channel slopes being under 1% and our area being under 2 acres. So that, and again, it will go through and calculate the slope to protect and the maximum, or the check depth as well as the quantity. So now let's go ahead and look at a larger area. In this case, it's downstream at the left side, 109.50 to 112 plus 0.0. It's going to be 5 acres with a rational C of 0.65, and our time of concentration is actually a little higher too. It's a little bit over that minimum of 8. And our slope in that range is going to be a minimum of 0.08, and the maximum slope will be 10%. And we'll try using the erosion control blanket. Go ahead and hit Control D, run our macro. You can see that our shear that we've actually calculated is actually higher than the permissible shear for erosion control blanket at 3.8 versus the 1 that's allowable. So you see the spreadsheet will actually highlight that we have a problem there. The shear is too high. So let's go back and try TRM1. Now you can see in this case it's the same calculated shear, and that's what happens with grass linings. It's just the permissible shear for the different linings is different from lining to lining. So for TRM1, it allows a permissible shear of up to 6 pounds per square foot. So the next thing we want to look at is riprap linings. So we've gone ahead and put another series of ditches in here from 112 plus 0.0 left to 114 plus 50 left, and put all of our information in. And we're going to start with a class 1A lining. So we'll go ahead and hit our Control D. Now you can see that again, there's a different area in the spreadsheet, a different cell where the converge is looked at for riprap linings versus the grass linings, the vegetative linings. But if we come over here, we see that the shear is calculated to be 5.85 pounds per square foot as opposed to a permissible shear of 0.96. So this will not work. Something else, and this is in the instructions, is when we do our riprap linings, the other thing we need to do is check to make sure that column CB of the maximum shear tab, we go over to CB, you'll see that it actually will check the D50, the 50% diameter, average diameter. And it's calling for a minimum, for this particular situation, a minimum diameter of 1.22 feet, and our class 1A does not meet that criteria. So we're going to go back over here and we'll try using class 2. And we will rerun our spreadsheet. And again, we see it converged. And we come over here. and we see we still have too much shear for that particular lining. And again, it's telling us to change our average diameter to a larger class. So we'll go in here and we will try a class 3. We have convergence again. See, this time we have a shear that is less than our permissible shear. And if we come over here, it says our class is okay. So it's calling for a D50 of 0.91, and a class 3 is a 12 inch, is a 1 foot average diameter. So that works for us. And just to show, we'll come over here, and a type 4, which is usually the rock from on site that's broken up to be a certain size. We'll go ahead and run that. And you can see that that works as well. And again, it's still doing our maximum depth of line, our 100-year check, and it is giving us our quantities. In this case, in cubic yards. I believe in class 3, we run that. I believe the quantity is in tons. So just to clarify on the thickness on the riprap linings, you can see that type 1A is 9 inches thickness. That's the Gabions. And you can also see that per the RDD 04005, that type 2 has a 15-inch minimum and a 24-inch minimum for class 3. And if we actually look at the drainage manual in chapter 504-4, it agrees with that as well. And it also talks about class 4, which is usually obtained from the job site. Usually it's an alternate to class 3, and we go ahead and use 24 inches for that one as well. We also don't want to forget to do our inlet and outlet ditches. Especially on the outlet ditches, we want to make sure that we do not just the channel lining, but we look at the scour analysis as well. And if required, we need to make sure that we have a transitional apron, which if you look in HEC 14, I believe you can see the design criteria for those aprons, as well as any other sort of scour countermeasures for outlets. Sometimes we end up with ditches where, for like an outlet ditch, we're really not supposed to use grass linings. We encourage the use of riprap linings, of the more rigid linings. Sometimes you can't get a class to work. In this case, I'm looking at the outlet on this one. So if I run it and come back and look at the maximum shear, you can see that it's not working for this. So sometimes we have to go to a grouted riprap. In a grouted riprap, essentially all we're doing, and if you look at the note we have on the quantities, we talk about a little bit. There's a note down here that actually gets printed with our quantities tab. Essentially, we grout in the top foot of the channel lining, and we assume a 20% void space, which we actually have in on our input. So if I go over here and pick the grouted riprap, okay, what it'll do is it'll go through and still run this, but it'll have an infinite permissible shear. You'll still go through and give you your depth based on the riprap and the roughness, and the check depth as well. And then again, we get the quantities, and the quantities include the actual riprap as well as the cubic yards of Class B concrete that is required. Again, based on the 20% void space over that first foot. The last type of analysis I'd like to look at is on rock cuts. We know that there's no actual lining with a rock cut, but I still want to go ahead and put in there and show you what it does. So I've got this entered, and we'll hit our Control D. You can see it runs it, and you can see it put in rock cut, and there's no real quantity there. Again, it'll do the 10-year with the maximum slope, but doesn't really have any sort of, has an infinite shear allowable. It did the minimum depth just to make sure that we're okay as far as how deep we're cutting into our rock cut and our 100-year check. Finally, if you just wanted to delete a line, it's just as simple as going through and deleting the data that you put in and making sure that in your pull down you go down to the blank, select that, and you can see that that it took off the information on the various tabs for that that item. So that's pretty much it. Please take a look at this spreadsheet. Let me know what you think. If you have any questions or comments, here's my contact information, and have a good day.